Ignition sequence start. All engines are running.
We have taken tremendous steps.
We choose to go to the moon before this decade is out.
We have achieved the earth-shaking, the breathtaking, the groundbreaking,
One small step for man.
and left a mark in the heavens. Our successes build one upon another and amplify what is possible.
The dawn of Orion.
It's time we take the next great leap. We're building the next chapter of American exploration, returning to the moon to stay, so we can go beyond to Mars, to expand what's possible and further our understanding. The architecture for these missions is already taking shape. We will go with new systems, bold designs, and a sustainable mission. You can hear it, taste it, touch it. We are going. We are training, testing, pressing our pioneering spirit into every component, defining our resolve with every line of code, and securing our success with every welcomed partnership. This is not hypothetical. This is not about flags and footprints. This is about sustainable science and feeding forward the advance of the human spirit. Because we are the pioneers, the star sailors, the thinkers, the visionaries, the doers. And because we stand on the shoulders of giants to go farther than humanity has ever been, we will add our names to the rolls of the greatest adventurers in history. Every day, every mission, we advance this calling. We are NASA. And after 60 years, we're just getting started.
Woo! Now, everyone, please welcome NASA Administrator Jim Bridenstine.
Thank you. I see the Jinx team here standing up, little standing ovation for an alumni. Thank you. Great to see you guys here. I want to be clear, I have no favorites in today's competition, although I did graduate from Jinx High School. All right, enough of that. You guys are getting way too much attention today. Just know this. Everybody in this room today has an opportunity to be part of something magnificent, which is what we just saw. The future requires us to have the best engineers, the best technicians, the best scientists. It is in our national security interest. It is in the interest of the security of the country that all of us love. That's why NASA is a sponsor of this event. That's why NASA right now puts $4.1 million annually into FIRST Robotics, and we've been sponsoring this event since 1995. We provide mobile shops. We provide mentorships with engineering, and of course, we provide dollars because you in this room are the future of us being able to accomplish those things. Let me tell you what the President of the United States has charged me with as the NASA Administrator. His very first space policy directive said this. He said, go to the moon. But he said, we're not going to do it in a way we've done it before. This time when we go, it's going to be sustainable. You saw in the video, this is not about flags and footprints. This is about a sustainable return to the moon. In other words, this time when we go, we're going to stay. And in order to achieve that objective, robotics is a big piece of it. And your generation is the one that will make it happen. And we have a bright future to look forward to. So he said, go to the moon sustainably with international partners, and we now have a coalition of nations on the International Space Station. We're talking about 15 countries collaborating and working in space now for 18 years. The high school students, yes, the high school students in this room. There has not been a day that you have been alive when we haven't had a person living and working in space to advance the human condition. And that's what this is all about. the science and the technology and the capabilities to elevate the human condition. And for a few minutes, I want to talk about what that means. In this room, people are familiar with DirecTV and Dish Network and XM radio and internet broadband from space. You're familiar with all kinds of different capabilities. I was a Navy pilot. We used to do over-the-horizon communications. We would zap high-resolution motion pictures all over the world. All of these capabilities for communications were born from this little agency called NASA at a time when it was nothing more than somebody's imagination, somebody's dream, and there were a lot of people that said it couldn't be done. Well, not only did the United States of America achieve space-based communications, but then we commercialized it, and now all of humanity can benefit from it, including when you think about the internet here in rural Oklahoma, we have internet broadband delivered from space commercially, born from this little agency that gets less than 1/2 of 1% of the federal budget. What an amazing accomplishment, but it's not just about communication. It's about navigation. People in this room are familiar with GPS. It's about the way we produce food. We're increasing crop yields now, reducing water usage, saving water, preserving nitrates in the soil. In fact, in Uganda in 2017, NASA was responsible for saving lives and mitigating a natural disaster, a drought. And in the course of that event, we saved the American taxpayer tens of millions of dollars because we didn't have to do disaster relief. Instead, we did mitigation ahead of time. These are the capabilities that are born from this little agency. And friends, these are the capabilities born from robotics and science and technology. And that's why we're all here today. But it's not just communication, navigation, the way we produce food. We're in Oklahoma. The way you produce energy, the way we predict weather. 80% of the data that goes into our weather forecast come from satellites in space built by NASA. The way we understand climate, the way we do disaster relief and national security. Friends, every banking transaction in the United States of America requires a timing signal from GPS. In other words, no GPS, no banking. That's a critical capability, and each one of these capabilities has elevated the human condition. We think about the electricity flows on the power grid, again, comes from a timing signal from GPS. Again, all of these capabilities that have elevated the human condition were born from this little agency that receives less than 1/2 of 1% of the federal budget. Here's the thing, friends. When they started the Apollo program to go to the moon, nobody had any of this in mind. And yet here we are. And that's why we support this event. That's why we support First Robotics. It is your generation that is going to take us to the next level, to the next step. And I want to go through for you just a few capabilities that we have ongoing right now. Anybody here interested in robots? We need to pull up a PowerPoint here. So we're going to do some exploration of space technology. The first robot I'm going to show you was actually 2 robots, Spirit and Opportunity. Anybody heard of Spirit and Opportunity? Two of these little robots were delivered to Mars back in 2004. We were just hopeful that they could last for 90 days and maybe make it 100 meters. That was the goal. And in fact, Spirit lasted until from 2004 to 2011, and Opportunity lasted until just about a month ago. What an amazing capability, born by NASA scientists, engineers, and robotics professionals. Now, because of Spirit and Opportunity, I want to share something with you. We learned some things. These 2 little robots demonstrated to us that there are minerals on Mars that can only exist underwater. Friends, Mars used to have water, not just a little water. The entire northern hemisphere of Mars was 2/3 covered in ocean. We now know that there's evidence of flowing water. What does all of this mean? If it has water, liquid water on its surface, it also means that it had a thick atmosphere. It also means that it had a magnetosphere that protected it from the radiation of deep space. You put all this together and it says Mars was, at one time, habitable. I'm not saying it was inhabited. I don't know. So don't go tell the media that the NASA administrator said that there was bunny rabbits on Mars. But I will tell you that at one time in its history, 3 billion years ago, Mars was capable of hosting life. I'm not saying that it did, but it was capable. Okay, let's fast forward. Curiosity. Anybody familiar with Curiosity? Well, just since I've been the NASA administrator the last year, we have made amazing discoveries using this robot on Mars. We now know that there are complex organic compounds on the surface of Mars. Now, that doesn't mean that there's life on Mars, but the probability just went up. The building blocks for life exist on Mars. I want to be clear. Those building blocks do not exist on the moon. They exist on Mars. And of course, they're all over planet Earth. And they exist on Mars in massive volumes. So there is something about Mars history that says the building blocks of life exist there now. What could have gone on in its history? We also know, because of Curiosity, that the methane cycles of Mars are perfectly commensurate with the seasons of Mars. Again, that doesn't guarantee life, but the probability just went up a little bit more. And just a few months ago, we discovered, not with this spacecraft, but with some of our international partners, we discovered that there is liquid water 12 kilometers below the surface of Mars. Liquid water, friends. Anybody know anything about liquid water on Earth? Wherever there's liquid water, there's life. We now know there's liquid water 12 kilometers under the surface of Mars. What does that mean? That means that there is a potential, and I'm not saying there is. NASA makes no predictions until we make discoveries. But 12 kilometers under its surface means that water is protected from the deep space radiation that comes from the sun. Again, doesn't guarantee life, but the probability keeps going up. Who in this room wants to be the engineer that develops the robot, or even the astronaut who finds life on another world? Anybody here want to do that? Friends, that's what we're trying to achieve, and right now we are following the water. This is InSight. We landed InSight on Mars in November, and it was an amazing day. This is a key capability that I think is important, and you, as the future technicians and robotics engineers, that you might want to consider. When we achieve something like this, we landed on Mars for the 8th time in human history. 8 times. The United States of America is the only country that's ever been able to do it. Others have tried and failed. We've done it. Now we're doing it with our international partners. All of the science and all of the data that we get, we give to the world for free. Why? Because it's science. That's why. And here's the thing. And here's the thing. When we landed InSight on Mars, we also were on the cover of 240 newspapers worldwide. Friends, NASA is an amazing tool of diplomacy for the United States of America. So we're talking about children in countries on the other side of the planet that maybe aren't always so friendly to the United States, seeing NASA on the cover of their newspapers and shaping their perception of who we are in the United States of America. This is an amazing diplomatic capability and an amazing soft power capability. InSight looks a lot like Phoenix, which also was a discovery on Mars. 2009, we discovered pure water ice on the surface of Mars. Pure water ice on the surface of Mars. All robotics, friends. That's what we're here to do today. More robotics. Okay, Maven. We talked about how there was water on Mars. Where did it go? Well, a long time ago, and again, I don't know, I wasn't there, neither was anybody else, but a long time ago, it seems like Mars might have had a molten core, like the Earth has a molten core, and because of that, it had a magnetosphere that protected it from the radiation from the sun. Well, that core cooled. The magnetosphere went away. Charged particles from the sun impacted the planet, and a lot of that water went out into space. Again, we weren't there, but we're trying to make assessments as to what happened. And this satellite, Maven, which is robotic, remember, each of these satellites, they look like satellites, they're robots. They have to work autonomously. You know, it takes 8 minutes for the signal to come to Earth from Mars, which means what it does, it is often making decisions autonomously. And of course, this is a little satellite we call OsirisRex. Over Christmas, OsirisRex entered orbit around an asteroid called Bennu in deep space. This robot, by the way, that's the first time in human history we've been able to orbit an object that small. But this robot is going to collect a sample from that asteroid in deep space, and it's going to bring that sample back to Earth, and we're going to be able to use really large microscopes to look at that soil and make assessments as to the origins of our own solar system. Very exciting mission. It's coming home in 2021. Anybody here want to see the samples that come back in 2021? And here we have a satellite called Juno that is getting really up close and beautiful pictures of Jupiter. I'm going to accelerate here. Cassini. This is an amazing capability. Cassini was around Saturn for a long time, many years. And what it did at the end of its life, we determined that it was coming to the end of its life. It was almost out of fuel. And we were able to fly this little satellite between and through the rings of Saturn and really get amazing pictures. So I'd encourage all of you in high school, when you get home, go look at the amazing pictures from the Cassini satellite that we've had around Saturn. And of course, New Horizons. Does anybody remember in I see New Horizons, there we go. Anybody remember in 2014 when we flew by Pluto for the first time in human history and got those stunning images? Well, it might not be very popular these days, but Pluto isn't exactly a planet anymore. But I think it ought to be, so call it good. Here's what's amazing about New Horizons. After we flew by Pluto in 2014 and got beautiful images of it, we then got beautiful images of its moon, and then we went to another destination with it, 4 billion miles from Earth, the furthest object ever looked at up close by NASA. Anybody heard of Ultima Thule? This, my friends, is Ultima Thule. It's called a binary contact, and we did not know what we were going to see when we flew by this object, but now we've got beautiful images of it, and we're getting more and more science about objects that were the first objects in the solar system. All right, we're coming to the end. This is Astro B. Astro B is not a satellite in deep space, and it's not a robot on another world. Astro B is a robot on the International Space Station. It is a tool and a partner. We're launching it in short order, and we're going to put it on the International Space Station, and it is going to help our astronauts live and work in space. Think of having another crew member. Here's what's amazing. You can see Astro B has no arms, and he has no legs, or she, call it whatever. It has no arms and legs. What Astro B has is thrusters, because in a microgravity environment, it just floats around, and then it has little fans that push it around and go different places, and it does daily chores for our astronauts on the International Space Station. Anybody here want to build robots that go on the International Space Station or future space stations? And finally, we have robotics on the International Space Station on the outside. I know we have astronaut John Harrington here, a good friend of mine, Navy pilot, American hero. The first Native American in space. So John Harrington had the opportunity to fly on the International Space Station, and he had the opportunity to do a spacewalk, but I want to show you a video here. You can see that long stick that descends below the International Space Station there. That's what's called a robotic arm, and we're going to watch a little video here of how the robotic arm works. You can see the astronaut at the end of the robotic arm. This is a critical thing for the United States of America, and I'm going to tell you why. Because your tax dollars did not invest in that robotic arm. This is an international partnership. Canada, the nation of Canada, stepped up and said, we're going to do that. And friends, last month, Canada stepped up and said, we're going to be with the United States for the next 24 years in space, because right now we're building a space station that's going to be in orbit around the moon. Not around Earth, around the moon. We're going back to the moon to stay. We need a reusable command module that will be permanently around the moon, and we're going to have Canada providing a robotic arm and all those capabilities and technologies that enable us to do more science and more discovery than ever before. So what an amazing capability that NASA is for this country. All of these countries living and working together in space. We've had 103 countries doing scientific experiments on the International Space Station with robotic help. Friends, this is a capability that our country needs. We need each and every one of you to step up and take that next generation to go further and do more, because it's in the national security interests of our country. Friends, I'm asking you to help your country achieve more and help the world discover more and learn more than we've ever been able to discover or learn in the past. And we're going to be able to do it because of robotics. And that's why we're here. That's why we support this event. God bless you. Good luck. Let's introduce some of these folks that are going to be competing, but I think first we're going to do the national anthem. Thank you so much. Thank you for being here.